All right, everybody. This is the last section for we're finishing up chapter 12. We'll do 12.7 near the end of the semester because it's a physics problem class. It's a physics problem, and you guys get enough physics already. Let's do this warm up. We're gonna kind of wrap up all of chapter 12 with this problem. The only thing is, you know what? If we really want to do it, we could find B of T too. But let's see how. Yeah, fuck it.
No.
Let's do B of T.
No.
It's not a test problem. This is if you can do all this on on this, then you're set up for the exam. That would make a great exam with just one question for the entire test. That would be perfect. But I didn't do that. I broke it up over to 4. You guys should be happy.
Yeah, you screw up like one derivative and your entire test is wrong.
I like that the last test was we're oh, use yourself from the previous question.
Well, I think even if you had the wrong answer for the first one and used it for the second one, as long as you did it right for the second one, you still got credit.
Yeah. I took your wrong. If you did a wrong answer, I took your wrong answer and verified that you did everything correctly with that wrong answer for the next parts. That's what makes it take 8 hours to grade 10 problems for 35 students.
Thank you.
Yeah, I mean, it's a full day job grading your guys' tests. You guys,
Hard to give a check mark to a wrong answer.
I could do what some teachers have done in the past. I don't think that anyone's done it for calculus. Just make it multiple choice. Make all the answers similar, so you can't guessing is bad.
You know how depressing it would be to know that you have to get to a certain form in a calculus test when simplifying is so ambiguous.
So I was talking with Benita, Miss Harper, the other Calc3 teacher.
All the right answers, but he only wants one of them.
Well, if you did a multiple choice test, you do have to have all the right answers on there. That's how it'd have to be. I was talking with Miss Harper. I do need to show you guys the delta epsilon proof. She gave me an excellent reason as to why, and there was no way to argue with it, and I didn't want to. I think you guys need to see the delta epsilon, which means I might have to change the lecture schedule around a little bit, make 13.2 take a little bit longer. Because if you've never seen delta epsilon, there's some work involved. Although Calc3 students, you guys should have a lot easier time getting it than a newly minted Calc 1 student.
Since already fighting kappa, why we're just fighting rho as well?
Fine. What? Oh, well, fuck it. I like the way you think. You're right.
That should be too hard though. You can't just
Oh gosh, now it's rho as well.
You might as well. Isn't K equal to 1 over rho? You just have to. It just be the reciprocal.
Okay, so what things do we? Oh, I didn't really give you enough time. Let's make sure everyone's starting the same path though, and getting the right R prime and R double prime. R prime. What did you guys get for R prime?
R prime, -3 cosine t, -3 sine t, 0.
And it's a good idea. Eric said 0. We are going to be doing cross products. So we do need a third component. Cross products definitely require a K. If you show a cross product and you just have IJ, I'm going to F you. That sounded bad. I'm going to give you an F so quickly that yeah, that came out terribly. I heard it when I said it. You will receive an F on that problem so quickly because cross products are 3-dimensional. The very concept of them is that they make a vector that's orthogonal to the first two. R double prime, what is that?
3 sine t, -3 cosine t, 0.
What's the magnitude of R prime?
3.
I concur. That's a great word. I love the word
Something different.
concur.
You're just, like, I figured out 3.
Yeah.
Oh, wait, no, they're big numbers. It's like, that's 9 times 9, 15. That's plus 1. I don't know.
And that's 2.
Yeah, that's what I did. I factored out the negative for them. I factored out the thing with 3 squares. That's 9. There's also
See how this purple works.
it's multiplying.
So I mean, it makes sense.
Yes.
Ooh, I like this. This is a nice pen. This is like the one problem to rule them all. This like wraps up almost everything in 12.6 or chapter 12. What it doesn't have is shifting to arc length. That would have been great.
Now imagine just saying, now do this on arc length as well.
Right? Yeah, I know. That would be that would make it a complete test. That would take an hour at least. It'd take a long time to do.
Yeah, that's if you know what you're doing.
Yeah, you find the RS.
Well, couldn't you just do it in terms of T and then after plug in the F? Or would that?
Well, I'm saying, well, you could do it as an arc length parameterization, or you can do it as a RT. You can do it either way.
I was saying, like, if you have
Jericho's
to-
got a good point. If you calculate everything in terms of T all the way up to the binormal vector, you should be able to replace, if you calculated T in terms of S, you should be able to replace T with S in all of them. Maybe that isn't as exciting as I thought.
Because you can also just do it again. You can do it again.
Oh, so like do the arc length parameterization, but only still use T and then put S in afterwards.
Yeah, you do that, or you can put S in first, and then
I mean,
it'd probably be easier to do it. Probably be easier to do it in T and then plug in.
what is it?
Especially if you're doing it. Like if you put an S, on have like there's gonna be like roots. And then-
So I'm guessing, Jericho, you're done with this problem because you keep talking, right?
No. I can't concentrate. Sorry.
You can't concentrate because you keep talking. Focus. Try to do this. Warm up isn't a warm up if you're just warming up your mouth. Whoa, that was a burn. I like that. That was good.
That was a good one.
What do you guys want to find next?
The electric field some H distance away from
We're not doing the electric field.
Oh, I want to find the orbital trajectory of a satellite.
Electric field is in chapter, I think 14 or 15. It might be 15. I'll go look for you. I'll tell you what chapter it's in.
I hope I get it right.
Chapter 15. Endgame, calculus 3 endgame. We will get to electric fields. Or vector fields in general. Electric field is just a common one, so is the magnetic field. How does this yellow pin show up?
Wait, with that, I already forgot which one was.
I don't think that's a good idea. That
Oh my god.
that is very light. And
And I don't want to go away. What the fuck?
well, all right.
Oh no.
You just got a permanent marker?
No, this is definitely says wet erase on it.
Well, you have to wet the board first.
That's not what you have to do.
No, I did read. You have to get rid of the sign is negative sometime, or
No, the derivative of the sine is cosine, derivative of cosine is negative sine.
because you have to, there's no negative there.
Yeah.
Yeah.
That's what I did is I drew a line. I had a line. Yeah, but I couldn't.
I wanted to work on it so bad yesterday, figuring and then people started flooding.
Zach, have you finished the problem?
Halfway there. No, I'm not actually halfway there. Oh, okay, I gotta find two words. Doesn't look very halfway there. I know, it's like,
That's not very positive now.
how your class is going,
I
right?
feel like I did something wrong. Like,
My teacher, like, teaching us how to do the homework at different boards too.
Oh, no. Yeah, I feel that a little bit. Sometimes we don't do that. Feel like it's like something, and then we don't know how to do it until like that day it's due.
yeah.
I mean, you're SI, so take care of us.
True.
You have to get things done in a time. No, first, first test, definitely not enough.
I'm trying to find this.
Yeah, well, this is something my differential equations class. And it's definitely my differential equations class, so I spend like most of the time. just trying to
Professor
figure out
Jones.
the
Yeah,
problem.
Shouldn't the t vector be all be over 3? Is the magnitude of R prime?
yeah, but R prime has 3s in it. So it's gonna cancel out those 3s right there.
Oh, okay.
Yeah, I was just simplifying.
Okay, I see.
I think we accidentally wrote the same thing. both of them. I think we wrote
I
the
did,
same.
well, these are identical. T prime and N of T are the same because the magnitude of T prime is 1. Recall that N of T equals T prime over the magnitude of T prime.
Yeah, that's why I was like worried, because it looked, I thought something was wrong.
I do make mistakes, but that wasn't one of them. I will make plenty.
I just remember that. That it's just the derivative over the magnitude for like up to the binomial, well, up to the normal, and then after that it's the cross product, it's the binomial. Cross product between the two derivatives over their magnitudes.
I jumped straight to B of T being 001 without doing any calculations. Does anyone know why?
Sign.
Because you want to say you're the Z's, they're zero.
Z is 0 in both T or T and N, which means they are completely in the XY plane, which means my cross product has to be only in the Z direction. And since B is a unit vector, it has to have a length of 1. So I was quickly able to jump to 001, but a cross product would confirm that what I have there is correct.
So if we do that on a test, it's cool, right?
If you make a little comment about it, yeah. Like if you said T and N are only in XY, thus Z is, or B is in Z only, I would take that. B is a unit vector in Z. I don't know that it's like that on the test though. I'll have to look later. I don't think it is. I wouldn't do that. I like hard problems.
There's no Z, but there's no something.
Yeah, I like,
I don't know what
having
that.
trig functions is really strong.
We got flashcards. That should be flashcards.
You are not getting
I just
flashcards.
have it on my note. I just have it on my notes. Equations.
Yeah.
All right. Did everyone get that for T, N, and B?
Hold everything.
Well,
Yes.
them all in one.
No.
Individually. Write them all in one.
I heard yes and no.
A piece of the cake. We're saying yes.
It's a derivative of T, it's the same as. A bad.
He said it's also because T and N is the unit.
About B of T.
That was our.
N is T prime over the magnitude.
Can you explain again, like, what do you mean by that? That they're both the same plane or whatever? You said?
Well, you mean, like, I'm dividing T primed by its magnitude as 1. That doesn't change it. That's why it's the same. That's the only reason why it's the same.
He's always zero. So it's. Quite on the X, Y plane. Because it doesn't change over the B.
These are not wet erase. This is some bullshit.
Maybe you need spray.
Oh, it's one, actually, the one where you just spray the. Like-
Yeah, we have a few of those in class. There's dry erase and wet erase.
Oh, you're right. Wet erase. Maybe I didn't. I'll try it later. I got a squirt bottle in here. So what else do we gotta find?
You can like run either there.
Oh, the AWS.
Like,
It's pretty good. It's not really loud. Yeah.
They're a pain, it's a pain when you make a small mistake though. You spray like a huge chunk of your board.
You write the dot or
Yeah.
or like use a pivot on where you want to raise and then.
Yeah, it looks like there's a. Like,
Well, I'm here, but you can get one by one from his kitchen or something.
Can you guys see that color okay?
Yeah.
Okay.
Yeah, it's like radioactive green.
Close your eyes, you'll still see it.
Are you saying that our eyelids are gone?
Oh, no, I'm just saying it's so bright. Like, you got that what's an effect where you look at something for long enough or like bright, then you close your eyes, you can your brain remembers it. So like it, your brain remembers.
I think that's your cornea being fried.
Yeah.
Oh, no.
It's your cornea being fried. Because it's stored for like for a small amount of time, like a few seconds. It's not fact. Into that. Literally your short-term memory, like
Look at that.
your peripheral memory.
And gentle acceleration.
Which is neat. That's kind of neat. There's no acceleration in the tangential direction, which means we've got no speed going forward or no acceleration going forward. This is kind of like flying through the air, and the only acceleration is downward gravity.
Oh, wait, so it wouldn't be like a circle since we have the sine and cosine function? Or no?
Well, maybe.
Yeah. Oh, yeah, definitely. I was just giving a comparison of other vectors that don't have a tangential acceleration.
Oh, okay.
This is definitely a helix.
Oh, for sure.
It's a circle, actually. Circle. Should be a circle.
Oh, sorry, you're going from the same.
No, that one is throwing me off. We can look at the equation for it in a second. Let's calculate the cross product, and then we'll see what it looks like if we just did that, switch it to a y and x. How about that?
Y is there.
Nothing in the J hat. or I hat, nothing in the J hat, everything's in the K hat. And we got 9 cosine squared plus 9 sine squared, so 9K.
Let's say yes, sir.
Oh, and that's divided by the magnitude of V. So AN is 003.
So while it's going in a circle, it's constantly trying to go in the middle. You have a question?
Do we not take the magnitude of the cross product?
He was asking if you don't take the magnitude of the cross product.
You are right. It is the magnitude. Look at this. I told you I make mistakes.
It's slowly going insane.
Oh, because I took NFT.
And if
They already divided. the three
And
out.
even writing AN equaled 003,
Forgot that it just goes over 3. So got
it's a
rid of 3.
scalar, so it should just be 3.
I did that.
So the fact that I wrote 003 should have indicated to me that it was not a sub n, because a sub n is a scalar, not a vector. What does that mean? I can write A as? A of t is an or at times t plus an times n. So that's really just 3 times the normal vector, because at is 0. Does that match up? The normal vector is sine t and negative cosine t. And does that equal r double prime? Yes, it does. We come up here and look, it does equal that. So that's confirmed. There was no tangential component to acceleration. Now, what did we hear? Well, we wanted to do kappa. What's kappa? Kappa is almost identical to the calculations we did for AN. Kappa is r prime cross r double prime magnitude, which we just calculated was 9, divided by the magnitude of r prime cubed. So divided by 3 cubed, which is 1/3. So that's kappa. And to finish us off, radius of curvature is 1/kappa. Which is 3.
That's what I did wrong.
I feel like you should.
And to answer Zach's question, what is this equation? Let's take a look. So we have x equals 1 minus 3 sine t. And we had y equals 3 cosine t, which is confusing. But if we did x squared and y squared, what do we get? Do I really want to do that? Let's see, I could say x minus 1 minus x over 3 sine t. Opposite over hypotenuse.
Because that means I need to change this T into TS, then take rid of it. This is. You can probably do the same thing with this. This doesn't involve any change.
So y equals 3 cosine,
I mean, so
T.
far.
but this is equal to.
No, you're on today.
So cosine's adjacent over hypotenuse, so y equals,
This
Your dog, no, that's very dog.
Piece of form or to change maybe the number should be something for.
I was looking up,
RKT and KS should be the same number. It's just different way to find.
people don't do anywhere near like.
Yeah.
He was talking about
I'd
like
say
Gaussian fields. I was like,
Oh, no, that's.
you find what?
Yeah. If you're asking if you. Using like that. S or.
Yeah, that's the.
You get the same. All got the same page. Yeah, I can definitely.
But then he was talking about a sphere.
Okay.
He
You just
was
get
like, oh, we
different,
can like
you'll just get a different way of getting.
make a Gaussian field around it. I was like, you find something just far away from it, so you make like something that's bigger than the sphere, like Gaussian field, and then like integrate that somehow. But then he was saying this, he was saying something about it only works because it's radially consistent, like all the charge densities grow, right? And he's saying that's since that's consistent, it works. But that's I stopped watching the video after that because I was like, I don't know if that's gonna work with like a rectangle or any other shape that's not radially consistent. You know what I mean?
it's not a circle,
Okay.
it's an ellipse.
Right.
It's like nice.
Nice.
Which makes me wonder how I have, it can't be right, because the curvature should be changing. Something's off, I did something wrong here.
What is changing? So curvature should be changing, but it's not, and when
Curvature is changing. Yeah, curvature is changing on an ellipse. And my curvature is not changing, it's 1/3, which means that's probably wrong.
I think,
Yeah, that works.
and frankly, I feel like that would be wrong because looking at the vector, it does look like a circle since they both have the same focus of 3.
Yeah, but it's the 1 minus that changes it. What am I doing wrong in my work is the question.
What if the 1 minus just only displaced where the curvature, where the circle is?
I don't want to assume that. Because it's only on the X thing, it's only on the I component. X is literally 1 minus 3 sine t. I'm pulling it from right there. So X is that and Y is that. So like maybe I screwed up. I rushed do this part. Did I screw that up? X minus 1 equals -3 sine t. Divide by -3. And I get sine t equals 1 minus x over 3. That is opposite over hypotenuse, which
It's your
is,
y.
it's my y, isn't it?
The 3 cosine when you solve for when you.
I didn't put the
replace it.
3 in there, did I?
Yeah.
That changes everything. I missed that 3. That's why it's a circle. Okay, let's rewind this a little bit there. That's where the mistake was. So the 3's cancel. So I've got y squared equals 9 minus 1 minus x squared. And since this is squared, this is the same thing as x minus 1 squared. And we move that over, and yes, it is just a place circle. R equals 3, centered at 1, 0. There we go. Now kappa is constant. And, oh, well, shit, I already knew it was R equals 3. Some bitch. I could just jump to that from what I had. We said the radius of convergence was 3, and I knew kappa was constant, so I did know it was a circle. This is what happens when you don't use your brain all the way.
Well, I don't think you use 100% of your brain.
You guys ready for another one?
Yes, sir.
Sweet. There we go. Oh, let's start with A and A of N and A of T. Let's start with those. And if we've got time, we'll do tangent and normal. Go ahead and give that a gander. Is this definitely what I do? Is my concept of wet arrays completely wrong? Look at that. It's just coming right off. Look at me being wrong again. Jericho told me to use water, and I said, that's not how it works. And sure as shit, that's exactly how wet erase works. Fail.
I mean, it's called wet arrays.
Yeah.
I know. Hey, don't get mouthy. I already said you're right.
No, I'm just like, it's gotta really
Don't-
make you feel.
Don't rub it in.
I'm just disappointed.
Careful, you have a test next week.
Did I say?
Well, I know. I'm sure I was your hero all the way up to that point. Oh, damn, that's funny. That cracked me up. That's supposed to be an and sign.
Oh, you're talking about that. Oh, I happy with that. I was just talking.
Oh, it's already harder, isn't it? Oh, product rule. Oh, product rule.
That's just.
Pretty sure he's singing this on a test.
I just, whenever.
All students
I
are
just don't do it,
different.
and I just do the product rule, but when I change the bottom part to negative power.
I mean, yeah, it's technically easier if you want to do it that way. Just trying not to be confused. Because it's very easy to get them.
Wait, you just said, why do the product rule mean? No, I said, I don't do it, I just do the product rule. By I'm making the bottom part.
Oh, yeah.
Technically, you could do the crochet rule instead of that part by making one of them.
Yeah, that's what I thought he was saying. I was like,
Yeah, you do either way.
You could give yourself more energy. Why not?
You're a mouse.
Welcome to being a master.
Stop that one down.
Oh, so pretty much.
I think that might make finding the second derivative a little bit easier if I do some grouping. And now for R double prime, I am going to write I and J on separate lines.
Is it legal to factor out C, the E, the T?
You can do that, just as long as you do the derivative correctly.
Is it allowed to say that?
But it's works. You could be doing a circle product scroll. That's part of the circuit problem. I think that would go.
Oh, I see. Did you not?
18. Yeah.
I did, I'm doing something wrong.
We go there.
We didn't tell you to practice.
Well, this kind of cleaned up kind of nice.
Literally doesn't do it. Or maybe it's such a quick.
And that was R, that was the magnitude of R prime.
But it's quite a bit. All methods, you don't like puzzle games. If you like, you can like puzzle games and not like them.
I mean, yeah, it's not really like public. And I really, but I mean, even flat,
I'll pause for a second there, make sure everyone got that stuff. And make sure I got it right by hearing everyone else say that they got the same thing.
When I said you can factor out, you factor it like out of the vector, or is that to stay in the vector?
has to stay in the vector because it's still a key value.
You have-
It's still a value of key with the view. It would have to be some sort of scalar or a constant that's not a function of key to be able to factor it out of the vector.
So Jericho, you could have it like this. You could put the E to the T outside, but when you take the derivative, you got to do both sets.
Yeah.
So you could argue or get away with doing something like, well, R double prime equals, well, I'll leave the first one the same, or I'll take the derivative of the first one, and the second part stays the same, and I'm just going to leave the vectors as a whole. And then I could say plus, and now I take the derivative of the second part. Either the product is this part, right? The second part of the product is this part. Now I got to do just the derivative of everything on the inside.
Just having two vectors instead.
And you're still going to get the same thing, but you're more likely to fuck this up, to be honest, because it's easier to miss the product rule part of it. So these are added together. So R double prime would be, you could still have the e to the t out front. But now we're adding these.
I hate that. I like bullshit.
What?
So sometimes I hate that identity.
Which one?
All that bullshit just for root two.
That's something's off. That's not right what I have.
Oh, I started hating that. the
Oh,
fact
shit.
that
I should have just cleaned up right here, right? Look at this. I just fucking did this all the hard way. I see it doing that. This cleans up right up here. I've got cosine e to the t cosine t and e to the t negative cosine t. Those go away. I could have just been negative 2 e to the t sine t. And this one, the sines cancel. And I have 2 e to the t cosine t. That makes R double prime pretty easy. R double prime is looking a lot better now. If you stop to clean it up. That's much prettier. That's gonna make doing our next step a lot easier. This part's still the same. That's still the magnitude of R prime. This would have been a pain in the ass to do if we didn't clean it up. Keep that in mind if it shows up on the test. I don't remember what my test problems look like.
Sure.
Because I kind of like just throw numbers at the dartboard and see what sticks, and that's what you get for the test.
The zero is only the only for zero, so you can do the cost product. So I mean, when we do the event, we'll probably have to do.
Yeah, we have to do the event. Hey, yo, you dropped the zero.
Oh, yeah, you dropped the zero for the.
You didn't write zero anywhere.
What zero?
Your K,
Zero
your
for your
K.
K.
We don't have,
I never put it in. I didn't drop it. I just never added it.
Dropped it
Because
from
I
the beginning.
don't really need it until the cross product, but it's good practice to put it in early.
Exactly, that's what we're doing. Practice.
No.
Damn, everybody getting mouthy today. I like it. Fortune favors the bold. All right, what do we got for V dot A? What is V? V is this piece of shit up here. That's our V. I don't like it. But A is pretty good. A is looking nice. So what do we got? I think having this separated with the 2e to the t makes this next step harder. So I'm going to put it back in. That's a negative. All right, so I dot that with R prime. So I've got negative 2e to the t sine t times e to the t times cosine t minus sine t plus 2e to the t cosine t. I'm going to do this on 2 lines. This is going to get ugly. And then I've got the R prime part. That's my dot product. So let's do some cleanup here. What do we got? They all have 2e to the t, 2e to the 2t, right? And then I've got sine t, negative sine t. Let's put the negative over there. Negative sine t times this part right here. So I've got negatives, I got positive sine squared t, and then minus sine t cosine t. And then this has been factored out already. I've got cosine times that. I've got plus cosine t sine t plus cosine squared t. Well, that drops out, and this just equals 1. So v dot a is just 2e to the 2t. And the denominator is e to the t root 2, which just means this simplifies to e to the t over root 2.
What's this do? This says on top. Hey, Mr. Jones, what about the 2 that you had on top?
The what?
You just said that it was 2e to the 2t over e to the t root 2. What happened to the 2 on top?
There's the 2 divided by root 2. Oh, I put it the wrong way.
Oh.
There we go. That's better.
Oh, that's.
Because 2 over root 2 simplifies.
And yeah, I never talked about it. You multiply both top and bottom of the root 2, you get the root on top.
And I'm going to put that in parentheses right there and make it clear that it's not subtracted.
Oh, the algorithms. How did that algorithm?
And then I'll take the like make only with people that you don't want to do that.
Yeah, we don't have time to do V cross A. But there is a shorter way to find AN when you're on short on time. Like this is AT, this is AN, and this is A. So AN equals A squared, which in this case is magnitude of A squared, minus AT squared. So the magnitude of A, where is A? This is that's A. So the magnitude of that squared is we've got 4e to the 2t times sine squared t plus cosine squared t in the radical. So the magnitude of A is just 2e to the t.
No.
And so we're squaring that. So that's squared minus AT squared minus e to the t root t squared. So AN, rather than trying to do the cross product, is 4e to the 2t minus 2e to the 2t, which is just 2e to the 2t. So that's the quicker way of getting A sub n in this case. It's not always quicker, but it cleaned up pretty well here.
Quaru.
Oh, that's the
What?
the magnitude.
That's AN squared.
So.
You're right. That is AN squared. My bad. You're right. So we need the square root of that. Good catch. So AN equals e to the t root 2. So apparently AN and AT are the same. And this is actually making a perfect 45-degree triangle. 45, 45, 90. He was right. AN squared equals magnitude A squared minus magnitude AT squared.
Oh, because when I multiply, I just factor them out. I should have factored out. Oh. I figured out right, That's stuff from the beginning.
Oh, no, we're learning about speeds today. Everything I can break down that, the word, I'll break it
And it's
down.
9 o'clock, so you guys have a good day. If there's any questions, I'll stick around for a second.
That for home ec.
Try to do the review exam today, because we'll go over it tomorrow, but if you try to get it done yourself by tomorrow, then you'll know what you don't understand.
For sure.
And you'll be able to check to see if you're right.
Have a good day,
See
Professor
you guys
Jones.
tomorrow. You too, Zach.
You looking for a document?
More important subjects to learn.
Oh, wow.
Wow. I'm hearing a big fat F in your future, son.
Hey, this is
Unless you're
recorded.
saying Calc 3 is the more important course.
Now if I get an F, it's because you have a vendetta, and I'm bringing it to the dean.
Yeah, go right ahead.
It's on recording.
Go right ahead. I will delete this recording so fast you don't even know.
The hell? Now we're deleting evidence. Good thing I have a body cam
Evidence
on.
of what? What evidence?
Okay.
What evidence?
It's all right. It's all right. Eric will come to court with me.
Really?
Ooh.
He'll keep the court busy with his tales of army, and then they'll throw your case out. Have a good day, guys. Enjoy physics.
All right.
Never.
I'm just joking. Your class is equally as important.
Only equal?
Well, don't backpedal now.
But no, actually, in all honesty, like you do need. I mean, we couldn't do calculus. I mean, we couldn't do physics without calculus.
Oh, I know.
And it's not like a freaking Sir Isaac Newton
Well-
invent calculus.
I'll bring more physics problem this weekend.
Well, I will ignore them.
Later. Yeah.
Have a good day, guys.
Oh, man. See you, Mr. Jones.
See ya. Oh, is anyone else in there? Oh, you're already on.